if the water should overtop the dam and wash away some of the earthen embankment, the concrete that was left theoretically could fail. They couldn't figure out a way to make the dam compliant, and there was a lot of talk about just tearing the dam down.
Lake Janelle, located in the Richfield Heritage Preserve, was threatened with extinction. The preserve and the property are the former home of inventor Jim Kirby of the famous Kirby Vacuum Company. They, along with the Neal family and their fruit orchards, make up this historical piece of property. The beautiful 336-acre public park features extensive hiking trails, equine bridle trails, as well as camping. The hiking trails include a stretch of the magnificent Buckeye Trail, which runs through the property. The public can enjoy non-motorized boating and catch and release fishing on two lakes, Lake Linnea and Lake Janelle. It is the former home of the Kroll High Lake Girl Scout Camp. In an effort led by the Richfield Joint Recreational District and the Richfield Historical Society, the property was purchased in its entirety from the Girl Scouts in 2015 by the people of Richfield in an emergency save. But the lake remained in trouble.
The village and the township had to vote on the purchase of the park. And in that process, there were several tours. The biggest thing that we got feedback from was the beauty of the lakes. There's two lakes, there's an upper lake and a lower lake. So that was the real focal point for most of the people that came to look at the park. And once it got to the point where Lake Janelle might go away, that was the impetus for getting behind it. We decided we need to get the word out.
The Historical Society sent out a flyer that explained the situation, complete with questions for residents to answer. The feedback was overwhelmingly positive. Money was raised to save the lake by building portions of the dam to new and saving the existing structures. The lake and dam also have historical significance. Lake Janelle itself holds the honor of being the only patented lake in the state of Ohio. James Kirby invented a way to reduce the normal silt buildup that always occurs behind a dam.
He arranged for any dirty water to bypass the lake. On the main creeks that feed this lake, he built filter dams. Upstream of the filter dam, there is a drain, so water could pass through when it was at the normal level. But after a storm, or in the spring thaw, when the water level would rise, instead of going over the top of the intake dam, it would drop into a drain. And the drain led to big pipes that go underneath the lake and discharge out below the main retaining dam. That was to let the storm water out.
The overflow section, or the spillways, the principal spillway, was a technique that was called Amberson. And although it has an OG shape, so it looks kind of like a Roman OG if you know woodworking, it has that OG shape and a slanted back, the inside's hollow. And that's pretty unusual. That construction technology was probably common during the 20s and then pretty quickly lost favor. Big dams did it because they could go through and inspect, have inspection tunnels. For a little dam, it's really unique. For a non-engineer, he did a really good job designing and building the dam.
At the center of the dam stands the mill house, a National Historic Landmark.
Kirby based the design on a grist mill, which is really an ancient technology, at least from the Middle Ages of Europe. The overshot wheel, where the water comes in off the top, requires that you have a water source, which is high up, so you had to have a dam, you had to have a lake, and then you had the mill. So what Kirby did, he came up with the experimental design of the grist mill, so the wheel on ball bearings, so it would turn easily, and the bridge is the swinging bridge, which kind of is low. It's across the dam spillway, and when you're walking across it, your eyes are at the level of the lake surface, and it's just an unusual point of view.
Kirby's mill presented a problem for the construction of the dam. The engineers at Gannett Fleming worked hard at a solution. taking into consideration Richfield Joint Recreational District's limited budget.
It was a big complication, make no mistake about that. One, that it was a building. Some dams have buildings, but what they don't have are national historic landmarks, which the Kirby Mill is. So we virtually couldn't touch it. It's a small project. There's a limited number of mitigation strategies that you can use that are affordable to scale down to a smaller size dam. For this, it's usually something called roller compacted concrete or conventional concrete. Roller compacted and conventional concrete wouldn't work for Richfield. It was more than their budget could handle. And so the only option was to breach the dam or to try to get the armoring, and that's called an armoring mitigation, by using the articulated concrete mattresses so that we could put those over the soil and keep it from becoming eroded, and essentially the dam embankment became another spillway.
In what would prove to be an excellent partnership, Black Horse Bridge Construction was contracted to build the dam.
Plan was to raise the elevation of the slope a little bit, but when I got down there, was able to remove most of the rock, get it out of my way, and got rock teeth with a bucket and scraped it down to where I needed to go to get grade where it was supposed to be. Cut the wall because the 500-year flood level is below the top of the wall, to give another auxiliary spillway to allow the water to breach the dam and not erode the dam. Lay down the geogrid first to keep water from going into the surface of the dam, and then place the geoweb on top of that with gravel to let any groundwater run off of and not saturate the dam.
The articulated concrete blocks are a series of concrete blocks that are open-celled, and the way they function is in basically a matting scenario where you have cables running through and tying the individual blocks together. The reason they're called articulated concrete blocks is the mat, the way that it functions is it does allow some bending of these mats, so you can apply this concrete armoring technology in scenarios where you do have bends and turns. Each individual block, for reference, is about 18 inches long, 8 inches high, and weighs about 120 pounds. And each mat has about 20 to 30 on them.
So we had to look at a means and methods and construction means and methods that we could lift and get a 15,000 pound concrete mat by that historic structure in place without bumping it, damaging it, or something else. The other thing it complicated for us was it made the profile width into a trapezoid instead of a rectangle. Why does that matter? Well, the flume studies were all done in a rectangular shape. Dam safety was only comfortable if we made it into a rectangular shape. So that's what caused a little bit of a flare in the embankment there, because the building was there. Then we had to flare it to keep it as a rectangle where the main water is going to go. Normally we wouldn't have to do that. That meant the manufacturer had to cut special pieces, make special blocks that were cut at angles and things like that. So another complicating factor that normally we would not have to deal with. Each of those mats were tied together with stainless steel, 3/8-inch stainless steel cable, both horizontally and vertically, and then grouted into the sides so that it was one big mat, almost like mass concrete, but without the cost. There's 40% open area, so you can have grass grow. The flexibility comes from, unlike concrete, it needs to be flexible when water flows over it. It's open, so we don't get hydrostatic pressures underneath it. All those were advantages to this product that made it suitable here. This technology had not been used in the state of Ohio, had not been approved by the Department of Dam Safety until this particular application. The materials have been available, but shipping costs prevented them from being used. And they came out of Michigan and Indiana, Illinois. Unless you were close to those areas, it wasn't cost efficient. Now, with trucking costs being a little lower than they used to be and the material costs being lower than they used to be, this became a viable alternative. Although our contractor didn't have previous experience with this, they did get a training from the manufacturer, and they did a marvelous job putting the ACBs, which we call them, or ACMs, in place. Having a good contractor takes a more difficult or a challenging mitigation strategy, making it work.
Putting them together was a little bit of a challenge due to they wanted the cables weaved between each section back and forth and then concreted in, but once we got the gist of it, I thought it went fairly well. Aggregate on the dam section, before we applied the foot of select fill, we filled all the open cells in the blocks with 57 gravel. Because the select fill wouldn't really compact down into the voids in the blocks, so the gravel filled all the voids before we put the select fill, so you don't get, the select fill doesn't erode down into the block. unforeseen things that nobody knew was there. Created a little bit of a challenge, but nothing that we couldn't handle. You can't help but question why, but there's a lot of design going into it, and once you get through all that, you understand why it is what it is. Overall, the start went pretty well, but then about midstream, I would say it became a bit of a challenge trying to figure it out, but once we got rolling with it, everything went together, and I think the incomplete project looks pretty well.
I mean, we hit things that you don't expect, or that you do expect and you don't know about. It's probably a better way to say it. We did get in down on the right-hand abutment, and there was a spring, natural spring coming out. So we had to add a drain, take care of it. Again, when there's a good synergy between the owner, the engineer, and the contractor, if that's not a combative relationship, we were able to say, hey, you hit a spring. Okay, what do I need to do to fix it? Well, I'd like you to put a gravel drain in here. They give the owner a reasonable price and they do the work. And it didn't stop anything. Everything kept right on going. So a couple of those things, a good rock was a little higher than we thought it was going to be on the right side, but a little lower on the left side. And that's civil construction. We hit a drain, so we started chasing it. It went nowhere. So somewhere in the past it drained something, but today it did not. So we ended up putting our other drain through the outlet for that one and being able to keep the concrete structure. And again, that's important to SHPO, the State Historic Preservation Office, that we didn't change things. Again, you're able to keep this structure, but the drain it served was long since gone. The weather delayed some things a little bit, but boy, once they started working, putting those mats down, that's impressive. Had we done any other type of fix, conventional concrete, roller compacted concrete, we would have been months longer. And so that equates to a higher cost. Now the dam is able to pass the probable maximum flood, which it needs to do to be a Class 1 dam. And that concrete is covered with about 18 inches of soil on the embankment side. And that was important to the State Historic Preservation Office and also to the Richfield Board, that they didn't want this big white monstrosity reflecting heat and taking away from the beauty of the park. So that again, that made that, with the articulated concrete mats, that made that a viable solution. Frankly, it was the only alternative. Nothing else would work. The other alternatives were literally to take the dam down, to breach the dam and not have a pool, not have the resource for fishing. They were really getting to the point where all the other consultants had said, you have to lower the dam, you have to cut the dam down, that's the only thing you can do. And we brought them a solution that allowed them to have the dam the way it was, the way it will be in perpetuity. So I'm proud of that.
So Lake Janelle will live on, and there are many who should be proud. Saving Lake Janelle is the story of a community joining together with engineers and contractors in a spirit of caring for beauty, history, and preservation with an eye towards the future.
The design ended up working out really well, and I think it exceeded my expectations of when I had first heard about using articulated concrete block in this fashion.
It'll be there long after I'm gone. And I think they got something to be proud of that'll give them use for many, many, many years.
All the people that are involved that are interested in it, all the volunteer work, Jeff DeLuca, Bob Becker, very, very nice to work with. Their heart is into preserving this and bringing it back to making it a nice place to come and visit. I think it's nice that they're trying to preserve history. Oh, the Kirby house, the dam, the whole thing, it's got a lot of history to it. It's kind of interesting finding out the history after being here. I knew nothing about it, I only live a half hour away. It's nice to see that they're going to turn it back into something, make a metro park out of it. They're going to rehab the dam, and then I guess they're going to rehab the suspension bridge and bring it all to Mill House, bring it all back to life for a future generation and enjoy the area and use it for years to come.
I hope it continues on the path it's on, and we get the word out enough to where we get some more support. And from the extra support, we can use the buildings that are there to the best use we can put them.
This is a phenomenal place, but the future really depends on if we can raise enough money to preserve some of the historic buildings and preserve some of that Kirby story and preserve the Neal story on the other end of the park. And it really all depends on what the larger community chooses to do.